Hey guys, welcome to another episode on my channel. So today we are going to talk about LoRa. LoRa stands for long range, and how long that range actually is. For example, with this model that is named Lora Ra, you can reach up to 7.5 kilometers with ease. Although I tested with 6.9 and it worked just fine. And in what situation you are going to use something like this? Well, I can tell you what I'm using this for. For example, when I'm building some home automation system or some other kind of smart systems, I'm using these transceivers in order to communicate between main unit and some remote unit. Like when you have home and you have a garden maybe a few kilometers away or garage few kilometers away. In that remote unit you are going to have maybe 2 or 3 or more microcontroller units. And in order to transfer instructions from the server to these remote units, I'm using these devices. And this is maybe the best use of it because LoRa has only one significant problem, and that is bandwidth. Its bandwidth is up to 50 kilobits. So if you want to do some video streaming or something like that, forget it. But for technical purpose like sending instructions or sensor readings, it works just fine. Now, what about frequency? This is really important part. This particular model is designed to work on 433 MHz, and that is not the only frequency LoRa can operate on. But whenever you are buying some radio transceiver, you have to be really careful about frequency, because not all of frequencies are available to you. Actually, few are. Because in every country there is something like frequency governmental regulating body. And there are some frequencies that you can use, most of frequencies you cannot. And for some frequencies you could actually gain permission, like in case of radio amateurs. So for that purpose it's strongly recommended to check law in your country about available frequencies. Because don't get me wrong guys, but penalties for broadcasting on some not allowed frequency can be huge. So you don't want to get yourself into that kind of trouble. And aside of these two, you have actually a bunch of different models of LoRa devices. But I'm most familiar with these. So now let me show you how to wire them up. Okay, first we are going to put this wiring on the paper. I'm going to show you how to connect Lora Ra to ESP32 and to ESP8266 microcontrollers. And I'm using D1 models. So for your own particular model, you are going to check pinouts. So first I'm going to show you with ESP8266. Okay, this side is going to be ESP8266. This side is going to be Lora Ra, and first, of course, it's 3.3 volts together. Then ground to ground. Now pin D8 to reset, pin D1 to NSS, D5 to clock, then we have D7 to MOSI, master out slave in, then we have D6 to MISO, master in slave out, and we have one more. We have D2 to D100. Okay, and now let me show you how to connect ESP32. So we have ESP32 with Lora Ra, so of course 3.3 volts to 3.3 volts. This particular model works on 3.3. Then we have ground to ground. Then we have IO 26 on one side, on another we have, of course, RST. Then we have IO 5 on one side, we have NSS on another one, we have IO 18, on another side we have clock, CLK, then we have IO 23 goes to MOSI, then we have IO 19 goes to MISO, and we have one more, IO 35 goes to D100. All right, so check this out. Now let's do wiring. Okay, I have my ESP8266 and my ESP32 microcontrollers. I'm going to bring these two LoRa devices in here. We are going to need some female to male jumping wires and some male to male jumping wires. So I'm going to take power supply from the single place. So I'm going to connect power from this board to my breadboard, and from that place I'm also going to connect power to this second microcontroller. So 5 volts from here and ground. All right. Five volts and ground. Okay, first let's connect power to LoRa devices. Ground to ground, 3.3 volts directly from microcontroller. Don't connect LoRa device to 5 volts, please. It would be a really serious mistake. In here also ground to ground and 3.3 volts directly to microcontroller. Now, what is next? Reset pin from LoRa device to D8 on ESP8266. Also reset from LoRa to IO 26 on ESP32. Then NSS from LoRa to D1 on ESP8266. D1, it's this one. NSS from LoRa to IO5. Now clock from LoRa to D5. It's fourth from the right. Clock from LoRa to IO18. Now we have MOSI to D7, I believe. Yes, it's D7. Okay. And on another side, MOSI goes to 23. Where is 23? Yeah, it's here. Now MISO and D6. Yeah, the only one in here, middle one. What's wrong? It's well now. Now on ESP32 side, MISO goes to IO19. And at the end we have D100. It goes to D2. Okay. And on this side of ESP32 goes to IO35. It's in here. It's a bunch of wires, I know, so make sure that you wire up everything correctly. And now let's get to coding. So guys, if you have not already, please create another 2 projects in your workspace and set boards. With first one is going to be ESP32 development board because I'm using ESP32 microcontroller, and with second one we are going to use ESP12E. I am using ESP8266 microcontroller D1. And in both projects include this library. So this is not the only library for LoRa, but I'm finding this one working just fine for all of my purposes. You can try with another one if you wish. But for this example we are going to use exactly this one. So I have main.cpp for ESP8266. This is going to be a receiver side, and I have main CPP for ESP32. This is going to be transmitter side, and first we are going to do transmitter. So first I'm going to include SPI.h and include Lora.h. Now we have to set frequency, const long frequency is going to be 433E6. It's 433 megahertz. Then we have constant chip select, and that is going to be general public input output num, general public input output num 5. Constant int chip select. Now constant int reset, it's going to be general public input output num 26, and constant int interrupt is going to be general public input output num underscore 35. Okay, first we are going to initialize serial monitor with serial begin with baud rate of 9600. It's just fine. Now we are going to wait for that initialization while not serial. Then we are going to initialize LoRa by setting pins first, and we are going to set chip select, then reset, and then interrupt. No, it's interrupt. I'm going to change this to, in order to avoid confusion. Okay, INT. It's fine. And now we are going to call a LoRa begin, and we are going to set frequency. All right, but it's going to be better if we say something like this. So if not LoRa begin, because this function it's going to return boolean. So if we receive false, we are going to print error message serial.println. I'm going to say LoRa init failed. Then I'm going to say not sleep, this is not Python, delay of 2 seconds and return. So if LoRa is not initialized or if cannot be initialized, we don't want to proceed. Now if everything is fine, serial.println, let's go. All right, this is all that we have to do in void setup. And now in void loop, what we are going to do, we are going to say LoRa, then begin packet. In first line, LoRa println, this is going to be our message, is the message from ESP32. Okay, now LoRa dot end packet and LoRa dot not flush. All right, then I'm going to print something like it's working and delay of 1 second. So what I'm usually doing with transmitter, I'm sending message usually once per second, and with receiver I'm reading for the message usually 10 times per second. You can tweak these settings yourself, but I found that this time difference works the best in my case. All right, so I'm going to save this. Now let's do receiver side. Of course, we are going to include in here also SPI, and we are going to include LoRa.h, but I want to show you something that I promised in here. It's not important for the purpose of this episode. With LoRa, you have one more interesting function, but you should check every single function in here. What I want to show you is on receive and on transmit done. If you want to set some custom function that is going to be executed whenever you receive some message, this is way to do. And also if you are transmitting, when your transmission is done, so if you are done with transmitting, this second function is going to be activated. We are not going to cover these two functions in this episode, but they know how to be really handy. Okay. This is what I wanted to show you. Now let's get back to this receiver side. We are also going to have a constant long frequency, also set to 433 E6. We are going to have constant int chip select in here, that is D1. Then constant int reset is going to be D8, and we are going to use constant int or whatever. I'm going to set it to D2. All right. We are also going to initialize serial with baud rate of 9600, and then while, what is this? IntelliSense. While not serial, do nothing. Okay. Now we are going to set pins for LoRa. So LoRa set pins. So we have chip select, we have reset, and we have int. Now also we are going to use if statement. If not, LoRa begin, and we are going to provide frequency. What we are going to do, we are going to print some error message, serial dot print ln, we are going to say LoRa can't be initialized. All right, we are going to delay of 2 seconds and we are going to return. All right, and if everything is fine, we are going to print message let's go, and let's go to word loop. So in here on the receiver side we are going to have one integer that is going to hold the size of LoRa message. So we are going to have LoRa parse packet. Okay, and now we are going to check not int if size not equals 0. That means that we have some message to read. And why I'm getting this error? Where? Yeah, equal sign. Okay. Now, because I'm sending a string over my radio communication, I'm going to receive a string and it's going to be called message, and I'm going to receive string from LoRa, read string. All right, and I'm going to print that string out. Okay, so with printf, I'm going to print message is and %s, and we are going to provide message cstr. Okay, semicolon, and at the end I'm going to say delay of 100 milliseconds. So not 1000 but 100 as I promised. Okay, I just saw one mistake in here, so it's serial printf, and I'm going to add new line in here. And now what I want to do more, serial print asterisk. Okay, while we are waiting for a message to come, we are going to print asterisk, then we are going to get that message printed to the screen, and then a new line. But first I'm going to build and upload my code for a transmitter side. So first I'm going to plug my ESP32 microcontroller, and we are going to build and upload this piece of code. Okay, I'm going to check project. It's for transmitter ESP32. I'm going to build this code and I'm going to upload it. Okay, that's beautiful. Now let's do with ESP8266. So now we are going to build receiver side. First I'm going to change project and then serial. All right, I'm going to build this code and upload it. Okay, let's check my serial monitor. Okay, what's wrong? Yeah, we have it. Message, this is message from ESP32. So guys, that's all for this episode. I hope that you learned something new and interesting, so please like, subscribe, and see ya!